Hello to everybody, it's Eugene. After a long period of idling, I decided to continue making my videos dedicated to construction of portable electromagnetic launchers of different types, especially reluctance launchers, also known as coil guns or gauss guns. In a previous series, I highlighted such a topic as voltage converters for these coil guns, and now we should move forward and go down to such a theme as brains of electromagnetic launchers. In this video I will show a few little hints about how to make them, and in the final part you will get acquainted with simple brain example of simple brain constructed on common types of ICs. Let's go on. Okay, what do we have here? It is a simple generator on 555 timer, which controls our power switch, and through this inductor or transformer is charging our output capacitor. So it is a simple schematic of voltage converter without any features like current limiting circuits, etc. It's only for general understanding. Okay, the voltage on our capacitor is controlled with this trimmed resistor divider, which is connected to some sort of comparator. The other output of the comparator is connected to some reference voltage, and its output controls the reset input of our timer and stops the generation when our voltage reaches its target value. Also some indication is reserved, for example with the help of simple lighting diode, and some control circuits which are present in our brain may be controlled from this output. Okay, this circuit may be realized with the help of discrete ICs, as I have wrote here, or with the help of special PWM controller IC, for example UC series, or by internal means of microcontroller circuit. Okay, what's wrong here? Imagine that our converter has charged the capacitor to its nominal value. The comparator reverses its output, the generator stops, this diode lights up, but as the conversion stops, the capacitor begins to discharge at once through this divider or through its internal leakage current. And as at the moment when it is discharged for a very little value, for example some millivolts, the comparator turns back, this diode lights down, and our generation continues. And as soon as the voltage, this delta voltage, is charged again, our comparator changes its output state again, etc. So we have ringing on its output with a frequency of from some hertz to maybe sound frequency. Our converter begins to buzz or to beep, and this diode is blinking chaotically, and on this output we also have unpredictable sequence of signals. So it is very bad for our system. What should we do? The solution is to add a second comparator and to tie its output to the reset input. of the timer, and to leave the first comparator controlling the indication system and other control logic. To switch this comparator, we should use the same divider with added small resistor between the trimmer and the upper shoulder. The nominal of this resistor should be small enough to ensure very small shift between the thresholds of these comparators. And comparing to the voltage of this capacitor, it must be 1 or 2 volts or even smaller. Okay, now when the capacitor is charged to the level of according to the threshold of the first comparator, it reverses its state, our indication lights up, and we obtain a solid control signal. Why it is solid? Because the generator is not controlled now by this comparator. It is controlled by the second one, which switches with some shift according to the first one. And this shift ensures that the ringing does not touch the first comparator, and it only influences the state of our generator and switch, and is enclosed inside our system. And the output signals, indication and control signal, are solid now. Another important feature which we must have in a portable system is controlling our battery voltage, because if we don't do that, we can destruct our accumulator by fully discharging it. How can we do it? By the same way, we should add another 2 comparators connected to the same reference, and which track the voltage on our accumulator with the help of this another divider of 3 resistors shifted for some value of this resistor. And the output of the upper comparator is connected with the output of the second comparator in system tracking the output voltage of the converter, and the other can be connected to some indicative system which says that our battery is in a danger state of discharge. This circuit functions in the same way as the first one. It means that when the voltage on the accumulator reaches dangerous values, the first comparator, it is number 4, says that the voltage is in danger range with the help of some indication system, for example lighting diode. And when the voltage continues to decrease, this third comparator reverses its state and stops our generator, our converter, which is the most consuming system in our coil gun. So we have some time when we see that our indication lights up. We have some time to, for example, switch off our system and begin charging our battery. And the last hint which I will talk about today is how to start our coil gun. It is a part of control logic already. And what is it about? If we have a multi-stage system, its stages are commonly switched by optopairs. I mean lighting diode, infrared diode, and phototransistor. And this diode is rather consuming detail. It may consume some tens of milliamperes, and if we have, for example, 10 or 20 stages, we can obtain already some hundreds of milliamperes consumption in idling mode. It is not very good, so we should have some system which strobes our detectors for the time of the shot only. And another side of this problem is that for example, especially in accumulator-driven coil guns, the projectile can jam in our barrel, and in this case, an according detector will work continuously, and according coil will melt, or our accumulator will blow up. So it is not very good too. So we should have some circuit which strobes our system for time. It must be, of course, longer than the time of the shot, duration of the shot. And in my system I choose, for example, 50 milliseconds. It is enough for nearly all cases. It can be realized in such a simple way as setting another 555 timer in monostable operation with this time setting resistor and capacitor, and in general scheme it is activated by low level signal connected to the second pin, trigger pin, with the help of some switch which is connected with its another pin to ground. But now in our system we have a very useful signal to control logic from the first comparator. It is low when our output capacitor is charged, so it can be used in such a manner as it is shown. And in this case our timer is activated only when our system is charged to an appropriate voltage. It is very useful because this protects our system from occasional shots when it is not desired. Okay, so we have the simple brain of our coil gun. It has all indicative features. It indicates our charging process, it indicates our battery, and it can control some multi-stage circuit which is arranged here. So it's as you can see, it can be realized by simple discrete ICs. These comparators 4 may be realized in a single LM 2903, for example, 2901, for example, comparator. And these timers can be assumed in one IC, an E556. It is double comparator in one case. So let's look how it is in reality.
Okay, this is an example of such a simple brain. Here is some inductor. It is off the shelf, and here is quad comparator. Here is double timer, and so we have all the functions we were talking about. Here is a matchbox for comparison of the size. It is a discharge circuit of 4 powerful resistors, and here is a battery of electrolytics. It is of about it has about 30 joules at 6 60 volts, of about 60 volts. Okay, this tumbler is connected to the outputs of the comparators. It switches on and off our generator, and this push button activates our short sequence. It means that this green diode must light up if we push it. Okay, the system is powered from this supply, and the levels of the dividers are trimmed to about to levels according to lead acid battery, i.e. If I switch it on now, it will be okay. Yes, we have only yellow diode lighting. It means that the voltage is okay, and if we, for example, let us trim the voltage to about, for example, 10 and 3 volts, and we have red light, it means that the level of voltage is rather low, but system is activated yet. Okay, so let us try to charge our capacitors. We will switch it on. Okay, the system is on, and now we can fire it. This green diode indicates that it is charged. This is the shot, and if we switch it off, it begins discharging. The diode lights out, and we cannot fire now. Okay, so this is an example of simple brain, and here is much more complicated brain I'm working on now, and it is for two-shoulder system of my powerful coil gun accelerator. I will show it maybe by summer. Okay, that's all. Merry Christmas and Happy New Year to everybody. Goodbye.